So we've got the PMC Power Supply back on the bench here that we looked at in a previous video. A couple of quick notes in the previous video. The diode bridge is actually sitting right here. I mean, it was obvious once I looked. So this little piece of heatsink right here actually is on top of the diode bridge. Looking down through the slot here, I can actually see where it's labeled CR6, the CR11 positive. So there's a diode bridge there. I just missed that completely when I was confused in the previous video. And the question becomes replacing this cap, which just, this was a piss poor installation. It was soldered in here and a couple of wire straps trying to hold it in place. So digging through my box of stuff, I've got a 2200 microfarad 40 volt DC cap. The supply is running at 35 volts, a little more than 35 when it's idling. It's getting kind of close, to the 40 volt rating here. At the same time, these holes down in here in the cap, if I can find something to point with, the two holes down here in the PCB are screw holes where screws on lugs like these would come up through, and I believe a cap would just sit on the board directly like this. And physically, this is a really good size. This is a used capacitor, but it's physically in really good shape, and I suspect it's got some life left in it. I've got another cap here, which is 40 volts DC, 50 volts surge, 12,000 microfarad. It's a big, big, heavy cap that could be perhaps mounted in here someplace. The problem is I don't really want to mount a cap up against the heatsink. This didn't get real warm to the touch during operation, but it might over time, and there's just no real great place to mount this in here without doing something up against perhaps the heatsink here. And the length of the cap really makes that tricky, because there's a step here that the cap hits up against, and so I couldn't get it flush, so I'm not super thrilled with that idea. I've got a bunch of these Nishikon 10,000 microfarad 25 volt caps. I ended up with just a whole slew of these really cheap, and they were Nishikon, which is why I grabbed them. And conceivably, I could series two of these together to get 5,000 microfarads at 50 volts working, which would be a really good solution here. But again, it's where do I mount them? How do I mount them? I could conceivably stick them on the heatsink here, but exactly, heatsink, heat, capacitor. These are rated at, I believe, 85 degrees C caps, so they're not really rated for high voltage. I really don't want to glue these on here or hot snot them on here on the end. I'm just not coming up with a lot of great solutions. This might be the best next step, just to see how well it works. And I think before I tear it down and put this in place, I may want to kind of bodge this in, redo the load testing we do before, and just kind of get an idea what the performance looks like. Debating here whether to just tear it down, put this guy in, cross my fingers, hope for the best. No perfect solution here. This is 5,000 microfarad and this is only 2,200. There's going to be more ripple at high load with this capacitor. At the same time, the physical size of where the original capacitor was mounted in here, just looking at the clearance on the board, this is about the largest diameter cap that could sit in here and clear everything. Height wise, it'll fit in the case, it'll mount via the screws, so it'll mount well. It's a Mallory cap, it's a decent cap. The 40 volts is a little concerning. It's it's a little close to the 35 operating. It's conceivable when this thing first powers up, that voltage surges up above 40. you know, I'm leaning towards this being the best solution, and then we can check performance. And while we've got the board out, there's a Rubicon cap sitting right here, 35 volt, 330 microfarad. I think I've got a good replacement for that. But it's a Rubicon, which does say there was some decent quality caps in here. I mean, Rubicon's a great cap. I'd probably go ahead and replace him at the same time. There are a couple more electrolytics here, these axial ones, that I might look at replacing. Really kind of trying to determine how the board comes out. You know, it's somewhat floating in here. It's really floating all the way to the back, which is really kind of an interesting construction. I suspect I can remove a couple screws here and the board would lift up out. The leads coming over to here all appear to be on connectors down to the board, not soldered directly on. There's obviously the edge connector there. So let's just kind of start to take this thing apart and see what we get. And then from there we can kind of decide how to move forward. And of course this requires me to find a Phillips screwdriver. Oh, that's tight. Let me get a real Phillips. I can actually get some leverage with. And you may have saw in that this whole assembly kind of dancing around here. There are two. These clip-on leads are windings on the transformer. I don't know that it makes a difference which is connected where. It may well to keep them in phase. I am going to need to release those. The board really is just floating in there. There used to be, or maybe not, there are. Look to be nylon standoffs. You know, I suddenly would have expected to see screws through these three holes here into those standoffs down below, but there really aren't. These look like back here they'll come off pretty simply. Hopefully it'll just pull off. I do want to tag these, so I just get them on the same orientation. Do that. Excuse me for stepping away. I just wanted to grab a couple of wire ties. And what I'm going to do is just mark the ones that were closest to this edge of the board over here with the wire ties, just so I can get them back on as they were before. Probably doesn't make a big difference, but it's a detail that, you know, I'm going to observe. That certainly looks like it should pull up off of there, and it does. And we're going to do the same thing. I'm going to wire tie the lead that was closest to this edge just to identify it. This is a great example of sometimes we'll just see a random wire tie on a wire like this. It just doesn't make a lot of sense. Well, somebody used it as a key, just as I'm doing here, just to help guarantee reassembly would go back the same. So these are the windings, secondary windings off the transformer. It's really unclear to me how that board is going to actually release here. I really don't think it's going to slide in far enough to easily release. Let me see if I can get this connector off of here, this edge connector, if I've got enough room, and I do barely. Let's see if we can get it kind of up here and out of the way, maybe. I really don't want to have to tear the front panel down here, because, you know, maybe I do. Yeah, I just realized that there are two Phillips screws that'll release this front panel. I was thinking it was a single piece of sheet metal for the entire lower chassis here, and it's not. That'll make things much easier. This will now tip forward, and we're in. So not too terribly horrible to get apart. I think this board is completely, well, not completely isolated, but very close. Close enough to work on. You can see here where they've added the bodge wires. The lead of that broken off capacitor came through the hole, was bent around and soldered here, and of course mechanical stress broke it off. The red wire's patched in there. I can clean all this solder off, drop in that cap, go ahead and replace this guy, even though it looks like he's probably okay. I may have some replacements for these axial ones as well, which wouldn't be bad to do. Diode bridge may have been replaced at some point based on the flux I see on the board. It's the same color as the flux around this cap. They probably did the bridge and the cap at the same time. It kind of indicates to me that the original filter cap on here may have shorted and failed. You can see in here these little nylon standoffs that'll line up with holes here in the PCB, and I'm just surprised that there's not like a, well, those are snapped off is what's happened. Yeah, there used to be a snap down on a little bit of nylon stuck up through the hole, and the board snapped down on, and somebody's broke those off. So the board is just kind of only being held in place by the two screws back here. And with the heat sink and the filter cap, there's some mass on the board. That's kind of a rude way to mount this. I will look through my mounting hardware to see if I can find something to replace these or get this mounted back down better. But can't part easier than I thought. Let's get something I can get some heat with going here. Do a bit of cleanup. See if we can get some of this large mess of solder off here. Clean this up a little bit. Waiting for the tools to warm up here. For this wire, I think we can just push it back up through the hole here. Just do that to release it. Come on. Lift out of there. Not that that solder's going to hurt on there. So I do want to remove much of that solder as I can and clean the board so we get a nice flush mechanical connection. We'll approach that here in a second. Trying to think of anything else I need to worry about here. We do have that cap right there that we're going to want to pull. The board is silk screened. With the orientation of the cap, so I'm just going to go ahead and kind of do the cheat here and just walk him out. The leads are bent over. Come on. Because the leads were bent over, it would have been a little bit difficult to get the soldering tool on there. Let's see if I can actually get some of this to flow. Let's see if I can just get some of this to clean off, get it to flow well. Again, get this to flow first. Pull off as much of it as I can. That's cleaned up reasonably well. Not unhappy with that. It doesn't look too bad. I'm just gonna, just with a bit of paper towel, just kind of buff that a little bit. There's not a lot of flux left there. The tin-plated foil actually looks really good to me under there, so I'm confident I can get a good connection in. Like I said, this is a used cap. It's labeled positive, and there is a red dot and a plus symbol. This cap goes in this way, and the question becomes, is the the spacing is correct? And it does actually line up. So this, for what it is, this might actually be a good fix, assuming this capacitor has some life left in it. Of course, the screwdriver you want is never where it should be. Make sure I get a good mechanical connection there. That the only difficulty with that, and I can see I need to remove it and make a mechanical change here. Only difficulty is going to be working around this to get those secondary winding leads from the transformer back on. Not a lot of clearance. I need to take this guy and lay him over here flat. It was originally laying down there flat, and I actually flexed it up. And it should have been standing up. Clean a little bit of the dust out of there since I have access. And that way, he was pushed tight up against the two pins here, and without laying down, look clear now. It's not perfect, but I think I can make it work. Looking at the layout of the board, I'd say it's definitely a hand-taped board. Why do I think I have the capacitor in backwards? Well, plus is labeled down there. The red lead came from there. I've got the capacitor the right orientation. We'll remount it here if I can get the screw to line up. Yeah, mechanically, this cap I'm putting in, I'm sure is extremely similar to what was in here originally. Yeah, it looks okay. There is some clearance there to get secondary windings on. That's nice. I need to find a replacement for here, 35 volt, 330 microfarad. Hopefully I have an exact, at least match. We'll find out. Boxes and boxes of capacitors here. That's not a great name in the capacitors there. I'll find something if I can a little bit closer. 1500, 2200. 1000. That's probably an acceptable substitute right there. I just picked him up to look at him and then set him down and he completely vanished. Oh, little capacitor, where did you go? 330 microfarad. I thought it said 25 volt. We have to watch this on camera to see if it just went poof when I set it down. I've always suspected that's what happens. Doesn't look like it rolled off the bench. This is 150, 33, now I'm going to make an executive decision here. I think this is going to be close enough. That was a 330 and this is a 470. Microfarad, brand new, 25 volt. I don't just off the top of my head remember what the voltage rating of the one I pulled out was. There it is. 35 volt. See, this is 25. So no, I'm not going to use that. Keep digging here. Everything I have here is 25 volt. You know, electrolytics are just something I don't have huge stocks of. Actually thought I'd have something that would work in there. Okay, we may have a little bit of organizer. A little bit of cheating here. No, it's not really cheating. As I can get really close. Sorry, doing math in my head here as I'm looking at ratings capacitors. I think I can do it with a couple of these. They're not as high quality caps as I might like. They are new. I can see the bulge in this guy in the bottom. So I think he is, or has become unhappy, just aged. What I'm going to do is take two 680 microfarad, 25 volt, and I'm going to series them, and that'll get me 330 microfarad at 50 volt. And this is 330 at 35 volt, so that'll actually give me plenty of room, working room for this. I've actually got, I think, plenty of room for these to sit down through the board side by side. It's going to be a little tight, but that's okay. So yeah, I can make this work. Decide how I want to do this. It's really going to be taking a positive and negative lead, soldering them together. Something like that. I've got lots of phenolic here, so this lead isn't going to short to anything. Wait a minute, now those are different physical sizes. What did I end up with? 680, 35, 680, 25. Oh, apparently there was mixed capacitors in the little bin here. And there are 680. Not super excited about these caps. They're not a great brand name. Wow, there's just a bunch of different 680 manufacturers in this little bin. I didn't realize just how many there were. Yeah, we'll use those too. Sorry, I realized I did that off camera. I've got the positive lead bent over on him. I want the negative lead bent over on this one. Kind of eyeball the lead spacing I'm ending up with, and that's a little too wide. I'd like it to drop in with very little mechanical stress. Still a little too wide. Not going to be the prettiest kludge I've done, but it gets me in a good rating area. Move the excess lead length. Oops. No, why does not want to cut? There it went. That'll get me what of course now I can't read. What were these, 680s? Yeah, 340 microfarad at the working voltage now. It's 70 volts actually working voltage, so which is plenty of margin. He's going to sit in here like this. It's awfully tight up. So again, there's a problem. It's really tight up against where the black lead from the transformer winding mounts. So that's sad. You know, I took out a real kludge and I'm putting back in a real kludge. I'm less and less happy with what I'm doing here. Less and less happy with what I'm doing. He certainly looks to me like he's bulging. No, 335 microfarad, that's pretty much spot on. .154 ohms, that's not horrible. He's holding at a kilohertz. I think the 10 kilohertz range is the range I blew up in the sky, and it is 100 kilohertz. Yeah, he's going to go back in. I think he is good enough for now. Next time I do a bulk capacitor or a large order from like DigiKey, I will order up a replacement. But for now, get this little supply back operational. He is good enough. Go ahead and bend the leads back over. Apply a bit of solder. I'm going to have to find some forceps, I think, to get the transformer leads on back behind here. Clean the potentiometers. Figure out what I'm going to do here. I hate those little posts being broken off. Somebody did this thing a big disservice by not taking it apart correctly, but such is life. So anyhow, I'm going to stop recording for a few minutes. Of course, this will get edited back together in something somewhat continuous, and we'll pick up later.